If you want to buy my notes, then check the link in the description below and install the app now. In this video, we will see magnetic circuit and its analysis. So here we can see this is the magnetic circuit. Now basically magnetic circuit is a closed loop or closed path containing magnetic flux. Now here we can see this is a flux, magnetic flux, which is represented by phi. And here this is the iron core and this is the coil. This N represents number of turns of coil, and here the current through this coil is current I. Now when the current pass through this coil, because of that it will be a electromagnet. So there will be a flux in this loop or in this path or in this iron core. Now here this phi represent magnetic flux in Weber. Now it is start point, its starting point and finish point. It is start and finish on the same point. Then this L represent mean length of magnetic circuit in meter. So here this L represent its mean length of this iron core. Then this A represent cross-sectional area in meter square. Again this N represent number of turns of this coil. And this is the iron core with permeability, relative permeability mu R. Now relative permeability of core material is represented by mu R, where this R represent relative and this mu represent permeability. So magnetic material with high permeability like iron, soft steel, etc. we use here. Then next is flux density. So flux density is represented by capital B and it is equal to phi by A, where phi is the magnetic flux and A is the area. The unit of flux is Weber and the unit of area is meter square. So the unit of flux density is Weber per meter square. Then next is magnetizing force, or we can call magnetic field strength or magnetic field intensity. So it is represented by H and it is equal to B upon mu, where this B is the flux density, magnetic flux density, and this mu is the permeability. Again permeability is equal to mu 0 into mu R. Now here again we can replace this B by phi by A. So if we replace this B by phi by A, then the expression will become phi by A into mu 0 into mu R. And its unit will be ampere turn per meter. This is the unit of magnetizing force, which is represented by capital H. Then next is H into L is equal to N into I. H into L is equal to N into I. So in place of H we can substitute this expression phi by A into mu 0 into mu R into L is equal to N into I. This Ni is the MMF. So from this we can find the value of phi. So phi is equal to Ni upon L upon A into mu 0 into mu R. Now here this is reluctance. Reluctance is given by S is equal to L upon mu into A. So here this mu 0 into mu R is mu. So reluctance is equal to L upon mu A, and this is the one more formula for flux phi. And also flux phi is directly proportional to N into I. Now Ni is equal to magnetomotive force MMF. That means as soon as the current increase, the flux will also increase, or as soon as we put the higher number of turns, then also the flux phi will increase. So flux is inversely proportional to reluctance. Reluctance is the opposition to the flow of magnetic flux, and it is represented by S. Now here we can see reluctance is opposition offered to the magnetic flux by the magnetic path. It is called as reluctance, and it is denoted by capital S. Then next is flux. So flux is equal to mmf upon reluctance. So this is one more formula for phi, mmf upon reluctance. So mmf is N into I and reluctance is S. So here we can see phi is equal to Ni is mmf divided by this, and this is reluctance. So Ni upon S. So flux is equal to Ni upon S. So this is the Ohm's law for magnetic circuit. We know that for Ohm's law for electric circuit is given by V is equal to I into R, where V is the voltage, I is the current, and R is the resistance. And if we take like this, I is equal to V upon R. Now here in electric circuit the current flows, but here in magnetic circuit the flux flows. There will be a force behind the flow of current, and that is EMF. The force behind the flow of current is EMF. But here in magnetic circuit, the force behind the flow of flux is MMF, magnetomotive force. Then resistance opposes the flow of electric current, and here reluctance opposes the flow of magnetic flux. So it is equivalent to Ohm's law for magnetic circuit. Here we can see current I is equal to EMF upon resistance. So this is the Ohm's law for electrical circuit, and this is the Ohm's law for magnetic circuit. If you want to buy my notes, then check the link in the description below and install the app now. Don't forget to like, share and subscribe to this channel, and thanks for watching.